Hi guys, welcome to Netgate Chemistry. So in this particular video we are going to solve some of the previous year questions of coordination chemistry which are being asked in the IIT JAM exam. So the first question given to us says that the observed magnetic moment of octahedral Mn3 positive, Fe3 positive and cobalt 3 positive complexes are these. So they have given the magnetic movement when there has been the octahedral splitting in the complexes of these three, and we have to find out the correct electronic configuration of these three ions in the complexes. So what basically we have to do is, see, first of all, the we have the complexes which are octahedral. So what will be the type of splitting in those complexes? That will be like this, right? These will be the d orbitals, these will be the set of T2G orbitals, and these will be the set of EG orbitals. So this will be the type of octahedral splitting in these three complexes. Now they have given Mn 3 positive, Fe 3 positive and cobalt 3 positive, right? If we look at Mn3 positive, then what it is having, it is having D4 configuration, right? If we look at Fe3 positive, then it is having D5 electronic configuration, and cobalt 3 positive is having D6 electronic configuration. So these are the d electronic configurations. Now they have given the magnetic moment values in these three complexes. So we know that magnetic moment will be equal to root under n into n plus 2, right? And the value will be in Bohr's magneton. So in case of Mn3 positive, the value of this magnetic moment is given as 4.95. Now if you square both sides and calculate the n value, so you will be getting n is equals to 4, right? Similarly, in case of Fe3 positive, root under n into n plus 2 will be equal to 6.06 given in this question. So from here you will get n is equals to 6, and similarly if you calculate here root under n into n plus 2, root under n into n plus 2 will be equal to 0 Bohr's magneton. Each are having unit of Bohr magneton. So from here you will get the value of n is equals to 0. So there are no unpaired electrons. Here n represent the number of unpaired electrons. Now we know the number of unpaired electrons, and now we have to find out the electronic configurations. So now it is very easy. So now if we look at Mn3 positive, before that here you are getting n value approximately equals to 5. So this is a little correction. Now if we discuss the first case, then what happens here is that we have number of unpaired electrons nearly equal to 4. So in order to have unpaired electrons equals to 4, having D4 configuration, in D4 configuration we want number of unpaired electrons equals to 4. So how we will be doing the filling? That will be like this, right? T2G3 EG1. This way we will be getting 4 unpaired electrons. So in case of Mn3 positive, we will be having configuration T2G3 EG1. Now in next case we have number of unpaired electrons equals to 5. So if we want to have 5 unpaired electrons having D5 configuration, so what we have to do is we have to do the filling like this, right? This way we will be having 5 unpaired electrons. So in case of Fe3 positive, we will be having filling as T2G3 EG2. Similarly, if we want D6 configuration having no unpaired electrons, then in that case what we have to do, basically we have one EG set and one T2G set, right? So this is T2G and this is EG. So basically what we have to do is we have to fill 6 electrons in such a way that we do not have any unpaired electrons. So the filling will be like this, right? Here all the electrons are paired. So in this case we will be having T2G6 configuration, right? So these will be the 3 configurations. So if we match these three configuration with these options, so now we have to look for the correct option, that you can look by yourself also, right? So the correct option is option C here. Okay, so this is the first question. With this, now we'll move on to the second question. Now in the second question, they are saying in the structure of P4O10, number of POP bonds. So first of all, in order to answer this question, we should know about the structure of this P4O10. So if you have seen the videos of coordination chemistry, then we have discussed about these type of complexes, similar complexes, so many, there are so many similar complexes which we have discussed. So basically, if you look at the structure of P4O10, then what it will look like. Cyclohexane type of a ring here, alternate P and O bonds. Now P will be attached with double bond O. Now above this we will be having a hexagon type of a structure like this. And here also P will be attached with O like this, P double bond O. Now these two P will be connected via oxygen, this oxygen like this. Okay, now this is the structure of P4O10. So you can go ahead and watch the videos of coordination chemistry, there we have discussed about these type of structures. So in order to answer these type of question, you should know about the structures of these molecules. So now you can count the number of POP bonds. So it will be 1, 2, 3, 4, 5 and 6. So the answer is 6. Right, with this we'll move on to the third question. In the third question, we have to find out the coordination number of aluminium ion and the bridging hydrogens, number of bridging hydrogens in this coordination complex. So for this also you should know about the structure of this coordination complex. If you don't know, then also by using your general concepts, some of the general concepts, you can make the structure. So basically we have aluminium ion as the central metal ion. Now we have NH4 ligands. So how NH4 will be bonded? It will be like this. So basically here my drawing is not so good actually, but if you can make a better picture of this overall complex. Basically aluminium is attached with these hydrogens like this. Here is the aluminium, we have 4 NH4 ligands. So one NH4 ligand is bonded to aluminium via 2 hydrogens. So basically we have 4 NH4. So basically there are 8 bonds between the ligand and the central metal, right? 8 bonds. Each of the bonds are with hydrogens of this NH4 ligand. Okay, so now you can make it like this also, right? So this is a better way to make it. Still it is not so perfect, but I hope you have understood the basic concept, right? So this is basically about the structure of this overall molecule. So here what you can observe is they want to know about the coordination number of this aluminium in the complex. So here you can see, here aluminium is bonded with 8 hydrogens, right? Out of one NH4 ligand, 2 hydrogens are bonded with aluminium. So we have 4 NH4 ligands. So basically we have 8 bonds between metal and ligands. So basically here you will be having the coordination number equals to 8. Now talking about the bridging hydrogens. So that also you can see here, number of bridging hydrogens are these, right, which are between aluminium and nitrogen. So these are also 8: 1 2 3 4 5 6 7 and 8. So basically there are 8 bridging hydrogens. So if we look at this question, so basically we have coordination number equals to 8 and number of bridging hydrogens are also equals to 8. So if we look at the options, so out of these 4 options, option A is the correct option, right? So far we have discussed 3 questions from coordination chemistry which are being asked in the IIT JAM exam. So I hope you are clear with these 3 questions. So far that's it for this video. If you have any doubt, you can comment down below. So far that's it for this video. Thank you so much for watching.